Hello and welcome to the ISS contact between the Kopernik Observatory and Science Center and Chris Cassidy on the International Space Station. My name is Drew Desker. I'm director of the Kopernik Observatory, and our contact will start in about a little over 20 minutes, but I wanted to do a very quick orientation for you about this program and what we do up here at Kopernik. Again, the Kopernik Observatory was founded back in 1973 to commemorate Kopernik's 500th birthday. The Kopernik Society, a group of Polish immigrants, people of Polish heritage here in the southern tier, decided they wanted to do something more than plunk a statue in a park and say, congratulations, Kopernik, for being 500 years old. So they built the observatory. We are a informal STEM education facility with 4 permanent telescopes. You can see on here we've got 3 scopes and domes. We also have a telescope that's called a heliostat that is specifically designed to look at the sun. And again, we do a number of programs throughout the year. Our biggest program is, of course, our big summer programs, which we are in the middle of right now. But we also do school programs and scout programs and public programs for the public, where people come up to Kopernik for a public program on some aspect of science or technology, and then if it's clear, we open up our domes and people get a chance to look at the heavens through our professional telescopes. As I had mentioned, we do summer camps, and this is actually the 28th year of summer camps that we've done. That's part of the Link Summer STEM Exploration. Link is actually part of the Link Foundation that helps us underwrite this program. Edwin Link, you might remember, invented flight simulators and the whole simulator industry, as it were. And the Link Foundation is looking to make sure we have another bumper crop of engineers coming through, so they help us with some of our programs. Normally, we would have the kids up here during the summer, but because of the pandemic, we are doing our program virtually this year. So we've offered camps for students in grades 2 through 9, talking about topics on like astronomy, biology. We've done various forms of coding, some engineering of sorts, construction engineering. We actually started to do a camp on virtual reality, which was a lot of fun. We've done programs on weather as well. And but our final program for this summer season is the one we're doing right now. It's called Welcome Aboard the ISS. This is for students that are entering a 5th and 6th grade. We're using, again, because we're doing this all virtually, we're using a video conferencing service to allow us to make this all happen. During the camp, the students have learned what does it take to become an astronaut, what kind of training they go through as the training for their missions. But then we also get into some nuts and bolts. We're going to have to track satellites, specifically the ISS. And how do we do that? How do we track the satellites across the sky? Also, how are we going to communicate to them over the radio? And we talk about how the radio works as well. What's been great about this particular camp is that we've had students from really, from a wide range of locales. We've had people from out in Illinois, Virginia, Pennsylvania, New Hampshire, and all over New York State. So it's been great to have them with us. So this program is actually it's called ARIS, which is amateur radio on the International Space Station, and that is what's allowing us to talk to Chris Cassidy on the space station. ARIS is actually the longest running experiment on the International Space Station. It's actually been on the space station since the year 2000, although actually there's been ham radio on the on spacecraft as early in the 1980s. Owen Garriott had ham radio on the space shuttle, and also we also had it on the Russian space station Mir. Now, in order to get an opportunity to speak to the astronaut, you actually have to make a proposal to the ARIS group and talk about what kind of your educational goals are, and if that aligns with what they would like to see happen, then we can we're offered a spot. We've been very fortunate to be able to do that. And let's see, we'll go to the next slide. All right, so Again, I'm a ham radio operator, and we're using the ham radio station that we have here at Kopernik, but we also have to have astro hams. We actually have to have the astronauts that are on the space station be licensed as amateur radio operators. And here at Kopernik, over the past 10 years, we've been very fortunate to have had 5 other contacts. The first one in the upper left-hand corner is Doug Wheelock, and Doug is particularly special to us here at Kopernik because he grew up 15 miles from here. And so it was great to have him as our, at least certainly my initial ISS contact. After that, we had Mike Hopkins. You see him in the cupola. Then we actually spoke with a Russian cosmonaut, Gennady Padelko. And what was fun about that particular contact was that we actually had one of our students who was a native Russian speaker. And at the end of the contact, we ran out of questions. And so one of our students was actually able to thank him in Russian for his time. And he was quite pleased with that. So it was nice to have had that way to sort of brighten his day a little bit. Finally, down in the middle, Jeff Williams, we had back in 2016, and finally Serena Chancellor in 2018. This year, however, we are going to be moving on, and our next astronaut, hamstronaut, if you will, is Chris Cassidy. Chris Cassidy will be our astronaut that we'll be talking to this afternoon. So what I want to do, though, is I want to show you a little bit of information about ARIS and what's about to happen.
Hi, my name is Ruth.
And my name is Chris.
You must be pretty excited to talk directly with astronauts on the International Space Station today. While we're waiting for the space station to come over your portion of the sky, let's talk a little bit about how it's going to happen. Of course, Mission Control is in contact with astronauts all the time, using a big radio with lots of fancy equipment.
However, we're going to be using something very different today. We are going to use ham or amateur radio to talk directly to the International Space Station.
When most people hear the word radio, they think of a music radio station, but it's so much more than that. Radio actually refers to the unseen energy that transmits all sorts of signals using electromagnetic waves. At first, people learned how to send signals like Morse code, and then they discovered that you can send so much more, like data, computer signals, and even TV.
Maybe you don't realize it, but you use radio every day. Maybe you watched the TV this morning, or you texted your friends, or maybe even you check social media like Twitter or Instagram.
Let's travel back to space for a minute. Since the beginning of the space age, humans have sent many spacecraft out into the universe. These range from the Hubble Space Telescope orbiting the Earth daily, and the Curiosity rover exploring Mars. We've even sent a long-distance messenger, the Voyager 1, who has traveled outside of our solar system.
Whether it's capturing a great picture of a far-off galaxy or conducting experiments on the space station, radio has to do with all of these. And today, you're going to be using ham radio. Now you might be wondering, what exactly is ham radio?
Amateur or ham radio is a service and a hobby where operators can talk with people around their neighborhoods, their cities, their country, and even around the world. Amateur radio operators require a radio license from the government. They're not that hard to get. I have one. My call sign is KM4LAO.
And mine is KD8YVJ. Our call signs are a way of identifying who we are to other operators. This lets everyone know that we have the proper license to using the radios.
As amateur radio operators, or hams as we are often called, we can talk with others about basically whatever we want, often science or some new radio gadget that we are interested in.
Let's focus back to the space station and your contact today. Many of the astronauts and cosmonauts aboard the space station are licensed ham radio operators. That's why your operators today can contact them. The people here, as well as the astronauts, are licensed to talk to each other, and you are allowed to talk over to their radio.
For our conversation today, we'll need an amateur radio station on the ground, either in this location or somewhere else around the world. We'll also need a radio in the space station.
NA1SS, NA1SS.
You can hear the calls coming.
Still. This is November Alpha 1 Sierra Sierra, the International Space Station, over.
On the space station, the radio transceiver is connected to an amateur radio antenna mounted on the outside. One of these antennas will be used today during our contact.
For our side of the contact, we need a good-sized antenna, a signal amplifier, something to make our signal stronger, and a rotator for turning our antenna. We have to keep our antenna pointed right at the International Space Station. And remember, it's moving across the sky and fast.
To aim the antenna properly, we need to track the path of the space station exactly. NASA uses complex systems to track the path of the space station and other orbiting objects.
The satellite tracking program we are using works out a complicated set of mathematics to provide the orbital location of the space station moment by moment as it moves through space. This information is sent into the computer that controls the antenna rotator, which moves the antenna to follow the space station. Maybe some of you have seen or worked with robotics. That's pretty cool stuff. And just like you can program a robot where to go, what to do, and how to get there, you can also program a computer to tell an antenna how to track the space station across the sky.
You know, it took a lot of planning to get this contact. Several weeks ago, the ARIS operations team had to figure out when the space station's orbit would pass over this location. Then, they had to talk with the planners at NASA's Johnson Space Center. The crew's time is pretty full, so they were able to find a time that could work for the crew members' schedules. Once they found times that would work both in space and here on the ground, the host organized this contact. And in just a few minutes, you'll be hearing and talking to the astronauts.
Well, it's almost time for your contact. It will be exciting, so good luck with it.
All right, so we're going to do one more little video. This is actually, I'm going to show you a video of a tour of Kopernik's radio station. So give me a moment and we'll do that. All right, well, welcome to the lobby of the Kopernik Observatory. We're going to take a tour out to the radio room and see what the radio system is going to be like. And next time you come up here, maybe you can get yourself on the landscape of Mars. On our way out there, you'll walk by our Astronaut Hall of Fame, where we actually have the 4 astronauts that have grown up in this area. Dan Birch from Vestal, Doug Wheelock from Windsor, Eileen Collins from Elmira, and Doug Hurley from Appalachian, who just returned on the Crew Dragon mission, Demo 2 mission. So we're going to head out the double doors toward the telescopes, which is where our radio room is located. Head down the hallway and enter the observatory, where we have access to the 3 telescopes, our Sarton 6-inch refractor telescope. We have a 14-inch reflector telescope there. We also have a 20-inch reflector telescope, which we use for imaging. And then this is the radio room. KHZRO is the ham radio call sign of the station here at Kopernik. And we're going to walk right in. And this is the radio station. So the radio itself is this device down here with the green display. Above it is a rotor controller, and this is the interface to the rotor that changes both azimuth and the elevation. The box above it is the computer interface between the rotor controller and the computer, and this is the computer that is doing the tracking. Right now you can see the ISS is actually going above the horizon right now, and we'll go out and take a look at the antennas and we should be able to see them moving. So we're going to head out into, we get some solar panels over here, and here are the antennas that are currently tracking the ISS. Of these 2 antennas, we're really only using the one on the right. That's the one that's cut for that particular frequency, and we should be seeing it move soon enough. as it's tracking. There it is, just a little bit. Just moves a little bit from time to time. It's constantly, checking where it's located in the sky and making an adjustment so that we can track it through the entire pass that we'll be talking to Chris Cassidy. And again, it has both an azimuth, which is the north, south, east, and west direction. Let's see if I can get a slightly better view of it over here. There's sort of in this area right here, that's doing the azimuth, turning it north, south, east, or west. And then there's another rotor right here that is rotating the antennas in whatever elevation is appropriate to connect to the space station. So that is what we'll be using as we talk to Chris. And again, this is some of the domes. The gray one on the left is the 20-inch. The one on the right is our 6-inch, and the one in the background there is our 14-inch reflector scope. So anyway, that is our tour of the radio station and an antenna setup so that we have here for Kopernik. All right, let's go to the last slide here, and eventually I'm going to show you a different screen that'll have a couple of different windows in it, one of which is this one that looks like this, and this is a screen from our tracking program. The white disc that you're seeing here is what's called the satellite footprint. That's how much of the Earth the ISS can see at any particular time. This little dot right here is our location, and so you'll see throughout the contact this white disc will start to come and cover up. So we are inside that white disc, and at that point, that's when we should be able to hear Chris Cassidy, and he should be able to hear us. So that is a brief orientation to what we're doing here. I am now going to switch over to we've got about 4 minutes left between now and when we should start hearing the ISS will be calling out. We've got a ham radio operator by the name of Gary Dewey. His call sign is AB2GD. He is actually at the radio right now and is making sure that all the audio comes both from us, from our video conferencing service, and also from the radio back into the video conferencing service. So we're going to stop our ISS, our little presentation here. Give me a moment. I'm going to switch to the All right, I apologize. I had myself muted here. So we are now about ready to, we probably got another 3 minutes, 3 minutes or so before the ISS should start to become visible. So again, this white disk that you see right here is the satellite footprint. That's how much of the Earth the ISS can see. We have a little dot right just above my hand here. That is, well, actually, I'm not sure you're actually seeing that, so I apologize. So let me see if I can bring that up. And yeah, this might be, so right in here is where we are located. And the ISS is at right over British Columbia. Now these students have rehearsed a bunch, and but like everything else, we just don't know exactly how well things are gonna work, and so we'll This is, in fact, our sixth talk, and let's hope it'll continue to be successful for us. It's always exciting. I've been a ham for over 50 years, and I still have goosebumps. Even just preparing for this one here. So, very much looking forward to it. So we need probably another minute and a half, and just before the disc gets over our location, I'm going to have Gary start making his call. And once we've established connection, our students will start to ask their questions. And so students, I take it you're all set, ready to go. And it's a beautiful day here. Fortunately at Kopernik, we're doing a nice sunny day. Although what's nice about radio is it could be cloudy, it could be rainy, and we still would be able to operate. So that's all working well. And let's see how we're doing. It's 14:22, so I'd say we've got about a minute, well, a minute and a half, maybe up to 2 minutes. And we were very fortunate that on this Expedition 63, they had two members of NASA, two NASA astronauts, Bob Behnken and Doug Hurley. They arrived on the SpaceX Crew Dragon. And as it turns out, Bob Behnken is a licensed ham, but Doug Hurley is from this area. And we had hoped maybe if he was still up there, we would be able to say a quick hi to Doug, but he came back safely, and we were just very happy about that. All right, Gary, so I think we're getting pretty close to where we want to start maybe opening up the squelch, and let's have you make some calls and see when we start hearing, hopefully hear Chris come back to us. So go ahead and place your first call, Gary.
NA1SS, NA1SS, this is Kilo 2 Zulu Romeo Oscar. Do you copy? Over.
All right.
NA1SS, NA1SS, this is Kilo 2 Zulu Romeo Oscar. Do you copy? Over.
Yes, sir. I'm clear. Good afternoon.
Good afternoon. We copy you, and welcome to the Kopernik Observatory and Science Center. Here is our first question. Go ahead, Tierney.
This is Tierney. Are there any germs in space? Over.
We do have germs in space. We've got people living on board a enclosed space, and we test and make sure that everything is safe. But every now and then we do see some evidence of growth because of people, and we have germs. Over.
This is Philip. Could you see the launch of Perseverance or fireworks from the ISS? Over.
We were in the area to see the launch of Perseverance, so unfortunately we could not. And fireworks are very difficult to see. I've tried a number of occasions to see fireworks, and I've been unsuccessful. However, if we are over our cargo ship, for instance, that's launching to come to the space station, we can see that rocket. Over.
This is Hussein. Do astronauts carry smartphones with them in the ISS? Over.
And we don't carry any smartphones with us. We do carry around a tablet, which has our procedures and things. It's only connected to the local area network. It's not connected to the normal internet. And we use it to work on all of our activities during the day. Over.
This is Lily. What sort of people work with astronauts? Over.
Hi, Lily. We have lots of different people. There's trainers and administrative folks that help us with travel, folks that help us with prepare for the space station. It's all kinds of different folks that work at NASA and our various space partners. So I would say as many types of people as there are, that's the type of people that we interact with. Over.
This is Jeremiah. What is the temperature like in and outside of the space station? Over.
Inside the space station, we keep it very comfortable, about 72 or 3 degrees, and so we just wear shorts and a t-shirt, and it's like a comfortable. The space station is a completely different story. In the shade, it's about minus 200 degrees, and in the sun, it's about 200, 250 degrees. So it's quite opposite extremes on the outside of the space station. Over.
This is Audrey. How long have you been on the ISS? Over.
Audrey, my two friends and I, we have been on board the space station for a little over 4 months, almost 5 months, and we have 2 more months to go. The three of us, Anatoly, Ivan, and myself, come home on October 22nd after 7 months. Over.
This is Antonio. Becoming an astronaut is an amazing life goal and accomplishment. What do you think you're going to do next? Over.
Well, Antonio, I've been thinking a lot about this very topic, and I think the first thing I'm going to do is get an RV and drive around the country with my wife and explore our amazing United States and all the beautiful places it has to offer before I think about anything else. Maybe do that for about a half a year. Over.
This is Nebula. If the ISS is traveling at over 17,000 miles per hour, it seems very hard for ships to dock with it. It's hard enough to hit a ping pong ball going 10 miles per hour. How do scientists and astronauts plan and execute these dockings? Over.
That's a very good question, Nebula. But in reality, it's about relative speed. So when we are going 17,000 miles an hour, our cargo ships also are going just about that fast. And so what matters most is the difference in speed between us and them. Imagine a car driving down the highway at 70 miles an hour. If you're staying on the side of the road, it seems to go by very quickly. But if you're driving adjacent to another car going 71 miles per hour, it seems like it passes very slowly. So that's the concept that we have here. Relative speed is what's most important to us. Over.
This is Eli. Do astronauts work on experiments from scientists from different countries? Over.
Yes, we have it's an international space station in all senses, including science. So scientists from all over the world put together their plan, and then their experiment gets decided and chosen to fly in space. And then astronauts from all different countries can work on that experiment from whatever country it's in. It's a very international team effort. Over.
This is Genevieve. What are your views of Earth from the space station, and what else do you see when you look out? Over.
Genevieve, just actually this morning I saw your Hurricane Genevieve, which is off the coast of Baja California today, and that is one of the things we look for is phenomena on the Earth, like hurricanes or large volcanic eruptions, burning the Amazon rainforest. We can see those fires, and so that's what we look for. We look for what's happening on Earth that's interesting for scientists as well as for us. Over.
Okay, this next question is for Nathan. Nathan's question is, how do you do liquid science experiments when you are working in space? Over.
We often work with liquid when doing experiments, and we often work with liquid in our daily lives when we're drinking water or iced tea, for instance. And you just have to be very careful with the fluid. But what really is important for liquids is the surface tension. I don't know if you've learned that concept in your science classes, but it's the surface tension that makes the water turn into a spherical ball. And that's something we often play with and experiment with. Over.
This is Josh. What happens when you have to sneeze while on a spacewalk? Over.
Josh, I've had that happen, and it can do one of two things. If you catch it in time, you can point your face down towards your neck, and it'll go kind of below the level of your visor. But one time I sneezed and I did not make it, and my all the stuff, all the boogers went onto the inside of the visor. Not a pretty sight. Over.
This is Ryan. Do you have seats that you sit in, and how do you stay in it? Over.
I have seats up here. We stay floating, and we use our feet to stabilize ourselves when we need to be still. And when it's time to sleep, we get in a sleeping bag and zip ourselves up. But throughout the whole 6 months up here, we do not really ever sit in a seat. Over.
This is Tierney. How do you choose what experiments to do? Over.
We actually don't decide. There's a team of experts on the ground in Houston and Moscow and Japan and Europe and Canada where they decide what the experiments will be. And when they get up here, the experiment is already decided, and the equipment is here, and the procedure to do it is already here. And we, as astronauts, we execute those decisions by the other people. That's how it works. Over.
This is Philip. Kopernik is in upstate New York. Did Doug Hurley tell you lots about our area? Over.
Well, Doug, a great friend of mine, and I've flown in space with him. This is my second time, so I'm very familiar with his part of New York where he grew up. And every time we fly over the Finger Lakes in particular, we both have. He tells me how to find his hometown from looking at the Finger Lakes, and yes, we talked a lot about it. Over.
This is Hussein. What do astronauts do in their free time? Over.
Time here in space, we generally like to look out the window and take pictures of Earth or the stars. That's our most of us think that we should take advantage of that while we can, because in just a couple months we won't be here and we won't have that opportunity. Although we do have movies and books and musical instruments, we can do various other things, but looking out the window is our favorite thing to do. Over.
This is Lily. How long did you have to train to become an astronaut? Over.
The time I got first selected until I flew in space, my first mission was 5 years, and that's about average. The first 2 years, you are an astronaut candidate, learning, you're basically in school, and then you're waiting. And then my second mission, I had to wait another 4 years before I flew again. So that's about how long. Over.
If there is, what does sunset look like in space? Over.
16 sunsets every single day up here, and it's unbelievable the colors that you see as the sun comes cresting around over the curvature of Earth. There's a few moments where you have this amazing sort of rainbow hue as the sun's peeking its eyes over the horizon, and boom, it instantly comes alive as it pops up over.
This is Audrey. When did you get interested in space? Over.
I got interested in space from a friend of mine in the Navy who had gone on to become an astronaut, and talking to him, that's what got me motivated. Over.
This is Antonio. Who inspired you to be an astronaut? What qualities did they demonstrate that you admire? Over.
Anyone SS, this is Kilo 2 Zulu Radio Oscar. Thank you for the contact in 73s.
All right. Well, we did it. Congratulations. That was great. We were very fortunate to catch him right as he came above the horizon, and then he didn't get a chance to answer Antonio's final question, but this was a great opportunity for the students to, again, ask an astronaut who's in the middle of his job. I say take your kid to work, but take your kid to the space station. And so anyway, we hope you enjoyed this as much as we did. hopefully, ARIS will be able to support some additional school contacts. You can watch on the ARIS website and this YouTube channel. And thank you again for watching. It's now time to relax. So long.